Right, let's have a look at part C then. It says, given that fx, even if you can't see that diagram, you can start by sketching that. So for part C, if we look at that, our f of x is equal to modulus of x minus 1 take away 2. Now, start off by sketching x minus 1. So this is x minus 1. And then if we look at the modulus, this now, anything negative is going to go there. This point here is 1. And finally, we are going to do modulus of x minus 1 take away 2. So now we need to shift the whole curve down and so we get something that sort of looks like this. We're going to shift the whole curve down by 2. Oops, I've not drawn that right, have I? Something that looks like that maybe. Now this point was 1, but if it shifted down by 2, this is going to be minus 2. If this was positive 1 up here and it shifted down by 2, this is going to become minus 1. So now we know that if we have one coordinate A, your y is minus 2 at A, so therefore A equals minus 2, and your B is going to equal minus 1 because that's the y-intercept. Does that make sense? Can you please let me know in the chat if you are happy with that? What else should I have done on this diagram which I have not done? There's one more thing which I should have done here, which is especially going to be useful for part D. That's right, I need to label the lines. I need to get the lines right. So this is going to become x minus 1 minus 2, which is x minus 3. This is minus x plus 1 minus 2, which ends up becoming minus x minus 1. Okay, this is going to be quite important for probably for part D for you. So have a go at part D. Let me know what you get as your answer or answers. Okay, so now we can see that the solution to that is going to come when I have minus x minus 1 equals 5x. So we get minus 1 equals 6x, and we get x equals minus 1 over 6. And that is the only value, because that modulus graph never meets the red line anywhere else. Is that okay? Any questions there? Now, within functions, there's something very important. We have to think about what type of function it is. Now, there is a one-to-one function, and that basically means every x value only has one y value, and every y value only has one x value. So examples of that might be y equals 3x, y equals 3x. If we, I don't want to use that. If we use a straight line and have something going through the origin, how do we determine if a function is one-to-one? All we need to do is draw one line going across and see how many times it hits the curve. So this here only hits it once, so this is a one-to-one. If we had y equals positive square root of x, if we sketch that, that looks like this, because let's say we had 4 here. Sorry. If we had 4 here, that would go up to there. Now, if I draw a line across, we can see it only hits the curve once. So this is a 1-to-1. Let's say 1-to-1 here. Okay. Now, another type of graph that you could have is a many-to-one, or a function. Now, an example of that might be x squared. Y equals x squared looks something like this. If I go across now, I get many x values to one y value. That's why it's called a many-to-one. So many x to one y. That's what this means. Okay. What about, can you tell me y equals x cubed? Is that a 1-to-1 function, or is that a many-to-one function? I want you to tell me in the chat, please. Right. It's a bit angry in there. All caps. Caps lock. If I sketch y equals x cubed, I get a graph that looks like this. If I stretch a line across at any point, I've got a 1. I've got a 1-to-1 function. At any given y value, there is only one x value. Okay, so be careful. This actually, x cubed, is actually a 1-to-1. Okay, this is a trick one, but if I gave you, I don't know, something slightly different, y equals x plus 1, x minus 1. Can you tell me about this? Is this a 1-to-1 function or a many-to-one function, please? Right, so if I sketch that, now I've got roots at -1, 0, and 1. But this actually goes up and down, doesn't it? It's got a maximum and a minimum. If I draw a horizontal line, the ray test here, I've got 1. But if I draw a ray at this height, I have got, in fact, 3 x values for that 1. If I draw a ray down here, I've got 1, 2, and then 3. And then if I go sufficiently far down, I get back to 1-to-1. So actually, this is a many-to-one. Okay, I'll be happy with that. Does that make sense? This is no longer a 1-to-1 because it has got maximums and minimums. And there are points where there are one y value has multiple x values. Can you let me know in the chat if this makes sense? Right, okay. Here's a challenging question. Find the range of x values for which this function is one-to-one. So the equation of the curve is y equals x, x plus 1, x minus 1. I want you to find the range of x values for which that is a one-to-one function. Okay, so before we can differentiate, we now need to expand the brackets. So x squared plus x, x minus 1. And so we've got x cubed minus x squared. And then plus x squared minus x. So we end up getting x cubed minus x as our y value. And so now if we differentiate that, dy over dx equals 3x squared minus 1. And so now to find your stationary points or your turning points, we're going to make the gradient equal to 0. And from there we get x equals plus or minus root a third. So what we have found, if I go back to the diagram again, is that the turning point here was positive root a third, and this here was minus root a third. Have I found my y values yet? Have I found any y values? No, I haven't. So I need to put this back into y to get my two y values. So y equals either positive 1/3 to the 3 over 2 minus 1/3 to the half, or we've got y equals minus 1/3 to the power of 3 over 2 minus and a minus is going to make a plus, and so we get 1/3 to the power of a half again. And so anything above your max was this point here. We can work out the exact value. So we're saying y greater than this value is going to be a one-to-one function. Y less than this value, sorry, it's the other way around, isn't it? So y less than this value, and y greater than that is going to become a one-to-one. Okay, does that make sense? Are we happy with that concept? Because that is quite a common, tricky question in exams. This is the one that students get wrong quite a lot. Well, let me know if you want me to clarify anything. All right, next thing that I'm going to look at is the definition of functions. A function is something where every x value has one y value only. Has only one y value. is y equals 1 over x a function? Is y equals 1 over x a function based on my definition? I want a supporting reason for your answer, please. Is it a function? Is it not a function? If we sketch this, the graph looks like this. Right, so we know what it looks like, but what about at x equals 0? There's no y value at x equals 0. So as it stands, not a function. Because x equals 0 does not have a y value. Okay, does that make sense? Any questions there? What can we do to turn it into a function? Because we can turn this into a function by doing something. F of x equals 1 over x. We can turn it into a function by doing what exactly? Not a transformation. All we're going to do is restrict our domain. We're going to say x does not equal 0. That's why with most of these questions they have x does not equal 0, be some number, because then every x value has a y value. Now x can be any value and there will be a y value. Does that make sense? So now it is a function. Because every single x value has a y value. All right. What about this? X squared plus y squared equals 25. Is this a function? Yes or no? With a reason, please. A many to one is still a function. The reason it's not a function is because one x value has multiple y values. We said a function only has one y value for each x value. Every x value only has one y value. This here, one x value has two y values. Therefore, not a function. Okay. And we can't turn this into a function either. There's nothing we can do unless we said y is greater than 0 or y is less than 0, but that's rarely done. Okay, so this is not a function because one x value has multiple y values. Right, okay. So you understood that. Now, the next thing I want to look at is domain and range. We've looked at domain and range when we were looking at parametric equations. So you should be okay with that. I'm going to go straight into this. All right, here we go. Have a go at this. Let me know how you get on, please. It's saying sketch f of x. Now, we've got some conditions there. It's saying when x is less than 4, the graph is 4 minus x. So that's a straight line that has a y-intercept of 4 and a gradient of -1. So it's going to look something like this. And that point there is 4. And this point here is also 4. Are we happy with that? Does that make sense for x is less than 4? So 0 is not part of the answer. Now we think about for x is greater than or equal to 4, the equation of the curve is x squared plus 9. So when it is 4, I get 4 squared is 16 plus 9 is 25. So at 4, I'm going to have a y value of 25. And it's going to look like a quadratic, something like that. Does that make sense? Are we happy with the sketch for f of x? This is x and this is f of x. Can you let me know in the chat if you are happy with this sketch? I'm just going to draw the bit for 4 again. That looks more like a quadratic, and that y value there is 25. Now, so we've sketched it. So just make sure you understand that for certain x values, you're going to draw certain graphs, is what this is trying to tell us. Now, in part C, part I, it's asked us to work out f of 3. Is 3 less than 4 or greater than or equal to 4? So obviously less than 4, so we need to use the equation 4 minus x. And so we're going to do 4 minus 3, which equals 1. So f of 3 equals 1 for C part I. Does that make sense? So we aren't going to draw the whole graph for both lines. We're only going to sketch the part of the graph that matters. Is another takeaway I want you to take away from this. Now, f of 10. What equation am I going to use for f of 10? Can you please tell me in the chat? What equation am I going to use to work out f of 10? Everyone to tell me in here. Because 10 is more than or equal to 4, I have to use the second part, x squared plus 9. Okay, that's the thought process. So we look at 10, is 10, which of these x values is more appropriate, or the right one? It's obviously greater than or equal to 4, so then I should use that one. And so we're going to use x squared plus 9. So this then becomes 10 squared plus 9, which is 109. We're not going to use the 4 minus x, because that is only for x values less than 4. Can you please tell me, if I just make something up here, am I going to use the first function or the second function to work out f of minus 3? First or second? And that's good. I'm going to answer your question just 1 second. So 4 minus minus 3, which is 7. That 25 is when I substitute 4 into this equation. So 4 squared is 16 plus 9 is 25. Okay. So what's f of 4? Can you please tell me what f of 4 is in the chat, everyone? The answers that are coming so far are correct. All right, you get the hang of that. So 4 is obviously not less than 4, it's equal to 4. So we're going to use the second equation, 4 squared plus 9, and we get 25. Now, for part D, it's saying solve f of a equals 90. What does that look like on this graph for part D? Can you describe what part D will look like on this graph? So the way I think about it is I need to draw a horizontal line at y equals 90. Let's just say I'm going to extend this line, because this is a straight line that's going to go up forever in that direction. This quadratic is going to go up forever in that direction. But then it says, when it says f of a equals 90, here is 90, and I need to draw a solid line across. How many solutions are there to f of a equals 90? Let's see, you can see that there are 2 intersections. There's x1, there's x2. Right, so now how are we going to solve that? It says f of a equals 90. The 2 solutions are, one was where 4 minus x equals 90, or I should, if your input is a, this should now change to a. And the other one was when you had a squared plus 9 equals 90. Do these 2 equations make sense? Can you please tell me in the chat? Are you happy why I changed it from x to a? Because our input is now a, we replace the x with a. So now we get that 4 minus 90 equals a, and a equals 86. Over here, we get a squared equals 90 minus 9. A squared equals 81. What are my a values from the right hand side? Well, I was waiting for that mistake. Oh, sorry, yeah, minus 86 there. When I take the square root, I'm going to get 9. I can only get positive a values. A can't be less than 4 because this equation is only for a is greater than 4. So do not take the negative root of this. Okay, it's not minus 9. A does not equal minus 9 because a can only be greater than 4 on this side. Does that make sense? All right, okay. Notice here they've drawn this circle because it does not equal 0. Should have remembered to do that here. So a blank circle to represent we do not include that value, and a solid circle to represent that we do include that value. Okay, please can you make a note of that in your sketches, for especially for exams. So the function is defined by some curves. When x is less than 0, we need to sketch x squared minus 6. So for that, I am going to draw a quadratic which is shifted down by 6. So at 0, we're actually going to start at 0, but we are not including the 0 value. So we're going to have an open circle and it's going to look like a quadratic there. Does that make sense for x is less than 0? Can you please let me know? We have to include, well, at the x value of 0, we're not including it, and that is sort of demonstrated with a hollow circle. So we're not just, because x could be anything less than 0, it's not saying x are integers. And then we are told that when x is greater than or equal to 0, we need to sketch 10 minus x. So that's now a straight line, negative gradient, y-intercept of 10. But at 0, we are including that. So I'm going to have a solid circle there, and I'm going to have a straight line that starts there and sort of goes on forever in that direction. Okay, does that make sense? And that is the full sketch. Can you please let me know in the chat if you are happy with that? Now, in part B, it says find the values of A, value or values of A such that S of A is 43. Now, I should actually point out that this is 10 and this is minus 6. Without which I'm going to lose, maybe if it's a 3-mark question, I've lost 2 marks, or maybe at least 1 for not noting these y values down. Now, S of A equals 43. How am I going to, what's that going to look like on my graph, part B? Can you please tell me what is that going to look like on my graph, part B? What I should be doing is drawing a a horizontal line at y equals 43. Now y equals 43. Actually, I'm just going to draw a straight line at 43, maybe somewhere over here. Oops. Here is the line y equals 43. That does not meet this straight line, it only meets the quadratic curve. So now we are going to say x squared minus 6 equals 43. The x value that I get from that, well actually I should be saying a squared, is negative. So a squared equals 49, a equals minus 7. Okay, does that make sense? Can you please let me know in the chat for part B? Well, so it's not that tricky really, it's not too bad. How are we going to do part C? Can you please describe to me, everyone? How are we going to do part C, sorry. What am I going to do in this case to help me figure something out, the answer to that? What I was going to say is draw the line y equals x. Sketch it on this diagram so that we can figure out how many solutions there are. And so, oops. I have something like this. And what I can see is that there are two solutions. There's one here and there's another one here. So for the first one, let's call this x1. We are going to say x squared minus 6 equals x. X squared minus 6, not minus 6, minus x minus 6 equals 0. X minus 3, x plus 2, x equals 3, x equals minus 2. Which one of these is the right x value, please? Is it 3 or is it minus 2? And why? More importantly, why? If we think about this, your x value here is negative. It's to the left of 0. So this one's not a solution. And then on the right hand side, the equation of this line here is y equals x. The equation of this line is y equals 10 minus x. Where are they going to meet? Well, they're going to meet when x equals 10 minus x. So we get 2x equals 10 and x equals 5. Does that make sense?